All right, the door is closing. Can y'all hear me? In the back as well? Great. I'm so excited to be here today. Wow, it's like some deep learning, right? I know there's a lot of AI and machine learning going on this weekend or this week, so I'm so glad to be here. Super excited. So, my name is Nora. I'm originally from Stockholm, but I've been living in San Francisco for the last 2 years. I'm a self-taught data scientist, and currently I'm bootstrapping a startup back in San Francisco. I flew in for this week, and what I'm doing, I'm building deep neural networks for cancer researchers to help them understand how their cancer cells are communicating, basically. And if there's something I wanted to remember me by, is that I love deep learning and I want to throw deep learning on everything. And by everything, I really mean everything. Just to give you a hint, I guess everyone here has tried to upload an ad to Blocket or to Craigslist if you're an American and you know the hustle or like the struggle. First you have to take a picture of something and then you have to write an ad, and the text is always like a bit confusing and so on. So I thought, what if you could build an AI that will write the ad for you just by showing it the picture that you're selling or the image or whatever you're selling. So it's a bit dark, but I built an algorithm that both understands images and how they are built, and it also knows the Swedish language. And so I uploaded this image. It's a couch. You can barely see it, but it's a pretty old, dusty couch. And you can see the white spots. It's where the algorithm is looking at the image, basically. So it looks at the back, at the seating, looks around, and then it writes a headline for it. And for this particular couch, it said, "Fin soffa I äkta skinn." It basically means nice couch in genuine leather. And it's pretty like, it's funny because it both understands different like textures, but it also knows Swedish like grammatically correct. So that's fun. It's just a silly algorithm, but I'm also working with serious algorithms like this one. I built this platform where I'm helping the cancer researchers to understand and see their cancer cells. So instead of having a human looking at this image, it's basically white. You can barely see any contours. You have an algorithm that is seeing the contours like super fast. In below 5 seconds or something, it will find all of the cancer cells and it will segment them for the researcher as well. So I built this platform for them. But let's talk about this talk today. Basically, you're gonna talk about how to build yourself a deep learning application using 3 easy steps, starting with the idea phase, finding something to apply the technology on. Later, a bit about data, the most time-consuming part, but also a very valuable resource and a prerequisite for a good model. And then the last part, which is training the model itself. So let's get into it. Bit dark as well, but when you think about state-of-the-art AI or deep learning, you might think about complex solutions like self-driving cars, or in my case, cancer research, or Google Home smart assistants. But what I really want to stress today, that it doesn't have to be that complex. It could be something that you're passionate about or an interest, or it could be like a day-to-day problem that you encounter, like that makes you annoyed, or it could be a mega trend like globalization or climate change or demographical shifts. In my case, the topic that I chose for this talk, I spend a lot of time in front of the mirror in the morning because I enjoy looking like this, and I guess there are other men and women out there doing the same. And because of that, I'm also looking at different tutorial videos for inspiration to put on the makeup in different kind of ways. The only problem is that if you search for makeup tutorial at YouTube, you literally get over 30 million results. And also, the beauty market being a $400 billion market tells you that beauty and makeup is a significant part of people's lives. So I thought, apparently it's not just me out there putting on a lot of makeup, because there's over 30 million videos out there. How do you bridge the gap? How do you know which video that will show you makeup that will work with your particular face and your particular facial features? So I thought, could AI do that work for you? Could AI bridge that gap? So that's the first part. That was my idea for this, and this is what the talk is built around as well. And just to recap, it doesn't have to be a complex solution. It could be something that you're passionate about, or as easy as makeup in this case. So the second step, data, and creating a data set for you. So deep learning has excelled in taking high-dimensional data and converting it into low-dimensional, discrete categories, basically. And high-dimensional data like videos, audio, images, text documents, and dividing it into discrete categories. In my case, I needed an algorithm that will tell me which one of these 30 million videos that will show me something that will fit my facial features, basically. So I need to find some data that to train this model with. So I started to examining or research facial features, basically, and there's a lot of them. You have a nose, obviously, you have chins, and eyebrows, the mouth section, but the most striking one and the most time-consuming in terms of putting on makeup is the eye section. So I started to look at eyes in more detail, and I narrowed down the problem itself, and I thought, what kind of data could I use to train a model that will find a video that will suit my eye shape or my facial features around my eyes? So the problem itself became an image classification problem, where I'm supposed to expose images to this network and having it tell me what kind of video that will suit my face. And I looked deeper into the eyes, and apparently there are 4 different distinct eye shapes. So there's round, one called monolith shaped, hooded, and almond shaped eyes. So it's time to create the data set itself. And I really want to stress this, because I Googled a lot to find some open data set to use for this, and I found a data set with hundreds of images of celebrities. So that's what I went with. I manually cropped out the eye section for each celebrity and divided it into 4 different categories like this. And I really want to stress this because you could use existing data sets and just applying your own knowledge to it to transform it into a unique data set for your model itself. So I really, really want to stress this part. Even though it might seem silly to use celebrities, you can actually transform that data set into something that would be very suitable for your particular model. And I divided these 4 eyes into 4 different folder structure. I cropped 200 images for each category, and then 100 more for validation. It's a pretty small data set. It looks like this. And the reason I'm showing you this structure, because I prepared a GitHub repo for you if you have a data set. If you prepare a data set, then you can just feed it to the repo that I prepared, and you can train your own model. It have a front end to it. So this is just a structure. How it trains. It's a pretty small data set. I would say 800 images for training and 400 images for validation. So the data, and just one more time, you can use existing data and create your own data set by applying your own knowledge to it. And the last part, which is training and visualizing whatever the model would see during the training. And just by show of hands, how many here works with neural networks? You. How many knows how a convolutional neural network, like operations, convolution operations? Okay, a few. Good, you too. Okay, so basically, you can either go with training a model from scratch. You initialize the random weights for it, or you could go with something called transfer learning, which is exactly what it sounds like. You're transferring knowledge from pre-trained weights into your network. And that's what I went with here, because I had a pretty small data set, and it's a common thing to do if you have a pretty small data set. And these particular weights are trained on a data set called ImageNet, which consists of over 1.2 million images over 1,000 categories. So in my case, I have 4 categories, but these were trained on 1,000 different categories instead. And what kind of architecture should you go with? There's a lot, ranging from fewer operations with higher accuracy to a lot of operations, lower accuracy. There's small algorithms, small architectures, and larger ones. The one I went with calls VGG16. And why did I choose this one? Because it's a pretty simple and straightforward architecture. It's easy to understand how the building blocks are built or in what order you could change different parts for your model. And it works really well for a simple classification problem like in this case. So, the architecture itself consists of 5 blocks, convolutional and pooling blocks, and one last fully connected block, and this is the part that will actually do the classification for you. Over there, and you have to, just looking at it in a horizontal way, you see how the high dimensional data, the dimension is reduced all the way down to a very low dimension, instead, and where it final images will be classified into these 4 different categories. So just look at each block consists of 2 different operations, one convolution operations and one pooling layer. And I just want to show you this part to visualize what the model will see when you feed the images to the model. So basically, all images can be represented as a matrix of its pixel values, like this image. It's very simplified. Since it's a color image, it's between 0 and 255, but let's pretend all the pixel values is either 1 or 0. So the convolution operation is where you use another smaller matrix. It's a transformation matrix. It's a filter, the 1 2 by 2 matrix over there. So for each step, it will slide over the input image and perform element-wise multiplication between the small matrix and the input image. And out of this, create a new matrix, a new representation of the image itself. So the multiplication output is added together into another matrix called a feature map. And this occurs at each building block all the way down to the classification itself. And it's all these where the dimension is not reduced, basically. The last step is the pooling step, and that's where the feature map, where the image you will just keep the most important features of that image. So you look at 4 by 4 like this, and then you take the most significant feature from that matrix, in this case number 2, and those 4 also number 2. And looking at the funnel, this is where the image is getting reduced in each step. So you just keep the most significant information in that image. Okay, back to that one. And since we're using pre-trained weights, we're going to lock all of those convolutional blocks. And instead of using a random matrix, as I show you, the one that slides over with 1 or zeros, all of these matrices that we're using are already trained and know what to look for in images. Like the first one, it looks for edges. And the second one will transform or invert the colors. So instead of using random filters like that, we're going to go with a preset that's already trained. And that's why it's called transfer learning, because they already know what to look for in each image. So that little particular filter will try to find all the edges. And the next filter will try to invert the colors to understand. And just as before, element-wise multiplication between 2 matrices, creating a new one. Just like that. And since all of these blocks are locked, we can actually look to see how the network actually interprets these images. And some of them are pretty scary. Like this one. It's like a demon, almost, and that as well. So it starts over here just inverting, and then when it comes deeper and deeper, it will just have to pick up the most important. We're forcing it to just keep the most important features all the way down here, and this part will help it to decide which category it belongs to, basically. And for the training, I used a nonlinear activation function called reloop, because all the operations so far have been linear to get like a nonlinear relationship between the parameters. For the last one, activation called softmax, which basically outputs their probability for each class. And in recap, I'm using pre-trained weights from ImageNet, trained on ImageNet. The architecture is called VGG16. I locked all the blocks, only had a fully connected layer, which were open. Dropout rate, just to make the model generalize better. And the last one, the fully connected, had a softmax for activation. And I ran 16 images at a time through the network until all the images passed by, and I did it 50 times. And it might sound like it's complex or a lot to do, but I just want to show you how few lines of code you need to create that entire network. This is everything it's built. I built it in a deep learning framework called Keras, built on TensorFlow, and implemented in a Jupyter notebook over here. So this is the base model, all the locked layers, basically. This is the little small top with the 4 categories. Here you just instantiate the model in Keras. You lock all the layers, telling it that you want to use all the pre-trained weights instead of retraining all of the small filters. Compile, train, save the model. So this is all the code that is needed to train the entire network from your own data, of course. So back to my classification problem. What kind of accuracy do you think the model achieved when I was done with that training? Any suggestions?
90%.
95? What did you say? 90?
70.
Sorry?
Sounds a lot like when you chose the maybe 70 or 80.
70, 80? Okay, you really believe in this algorithm. Nice, because it was between 90 and 93%, actually. I was pretty surprised. I was obviously glad that it worked, but it's a very good starting point. I mean, 90%, and then you can work with further optimization and hyperparametering and tuning and adding even more images. So it's a very good starting point, basically. So just to reiterate a bit, talked about the idea. It doesn't have to be a very complex solution. It could be something that you're interested in or something that you're passionate about. Then the data. You can use existing data and just convert it, applying your own knowledge to it, and to create a unique data set that works for your model. And then the training. It's just a few lines of code to get started, get a model that will work for you. And since I got over 90%, I got so excited, so I decided to build a product out of it. So I built a front end where you just upload an image, connected with a back end where the model is. Also very few lines of code, exact same code I showed you before, but a bit condensed. So the entire network is in this view in 15 lines of code, or even less. And to connect the front end with the back end, I used a web server solution called Flask for Python. It's a very simple web server framework. Also, like it takes the image from the front end, basically, shows it to the model, and then returns which class it should belong to, basically. So front end to take the picture, upload the picture to the backend then predicts the image, and then send it back which eye shape you have. And here's the repo that I prepared for you. It's already up there, so if you prepare a data set, you can just run it through all this to have it's a finished front end for it, and a prepared backend that will take care of the image itself as well. The front end in this case is built in React, so I changed it a bit. So just some conclusions before I'm showing you the app itself. I love AI, but the part that I love most is actually converting ideas into real products. And for me, it's also a very important part of learning to build something end to end. See if I can. So this is the website itself. And then it tells me I have round eyes. And it tells me what kind of makeup I should wear. There you go. There you have it. Do you have any questions? Start with? Yes.
Was it the VGG? Was it the first architecture that you chose, or did you like try others before and you landed on the VGG?
It was the first one I tried, and it worked really well. And it was my very, very first deep learning project as well. So it was pretty easy to start with that kind of network. So that's what I did. Yeah. Thank you. Good question. Shades, yeah, that's what I'm calling it. Quite a few actually. I have to add some more makeup because I just started as a side project. But yeah, I don't know exactly, but I follow it up and I have like all these graphs of people using it. So for in this form, I think like 8 months, I would say. Yeah. The model's been up for, I mean, I trained the model like a year ago, something like that. But then I built the front end and the entire infrastructure for it later on. Thank you. I'm gonna stay here for a bit. So if you have any questions you want to talk to me like one-on-one, I'm happy to answer questions. And also try the repo. You just have to find yourself a data set, and then you'll have everything up and ready for training. Thank you.